Hello my dear students. In the last video we discussed that the oxidation and reduction reaction and what is redox reaction. In this video we are going to discuss how can we balance a redox reaction. When a reaction is given, how can we balance, right? So balance term is very important in stoichiometry also. The main basic criteria to balance the chemical equation is law of conservation of mass. According to law of conservation of mass, in a chemical reaction, the mass of the reactant is equals to the mass of the product, right? The law of conservation of mass is proposed by the Lavoisier. He is also popularly known as father of modern chemistry. Okay, the balance term, balance word is very important in chemistry, and one thing should be remember, the balance word is also very important in our life also. In our day-to-day life we are using the balance word. A balanced diet we should take. When we should talk with our elders, we should maintain the balance, right? Similarly, we can maintain the balance in our atmosphere also, right? Otherwise, if the balance is not present in our atmosphere, the atmosphere or our surroundings will become polluted. So balance word is very important in our human life also, as well as in chemistry also. Okay. Now let us discuss the how can we balance a chemical reaction. What are the steps we should follow to balance a chemical equation? Right. First of all, when a chemical equation is given, a redox reaction is given, just you have to classify the redox reaction in oxidation half reaction and reduction half reaction. Oxidation half reaction and reduction half reaction. Classify the balance a chemical equation. Balance a chemical equation. Balance a chemical equation. Balance a chemical equation by ion electron method. Ion electron method. Ion electron method. Okay. Balance a chemical equation by ion electron method. In ion electron method, the first step is, step 1 is classify the redox reaction in oxidation half reaction and reduction half reaction based on finding the oxidation number. Finding the oxidation number. Classify the redox reaction. Classify the redox reaction into oxidation half reaction, into oxidation comma oxidation half reaction, oxidation half reaction, and reduction half reaction, and reduction half reaction. Reduction half reaction. Based on finding oxidation number. ON means what? Oxidation number. What is the first step? Classify the given redox reaction into oxidation half reaction and reduction half reaction based on finding oxidation number. That means when the oxidation number increases, that is oxidation half reaction. Oxidation number decreases, that is reduction half reaction. Okay. Now second step. So what is the second step? After classifying the oxidation half reaction, reduction half reaction, in the second step, see, balance the atoms other than oxygen and hydrogen. Balance the atoms other than oxygen, and hydrogen atom. Balancing the atoms other than oxygen and hydrogen atoms. Right? Okay. Now, third step. Next, balance the oxygen. It is very, very important. To balance the oxygen, we should add water molecules. We should add required number of water molecules on deficient side. On deficient side. To balance oxygen, or oxygen atom, we should add required number of H2O molecules. Required number of H2O molecules on deficient side. On deficient side. Okay. To balance the oxygen atoms, we should add a required number of water molecules on deficient side. Okay. Next, fourth one. Here, after balancing the oxygen, we should balance the hydrogen. To balance the hydrogen, or H atom, to balance the hydrogen atom, we should add required number of H plus ions on deficient side. Okay. To balance the oxygen, we should add water molecules, a required number of water molecules on deficient side. To balance the hydrogen atom, we should add number of H plus ions on deficient side. Here, to balance the hydrogen atom. To balance the oxygen atom, we should add H2O molecules on deficient side. After balancing the hydrogen, remember here, to balance the hydrogen, add H plus ions, number of H plus ions on deficient side in acidic medium. It is important. In acidic medium. That means we can balance the chemical equation in acidic medium and basic medium. In your examination, the question will ask balance the chemical equation in acidic medium. Then you can balance the hydrogen atoms by adding number of H plus ions on deficient side in acidic medium or H plus. Okay. We can represent also in the chemical equation acidic medium as H plus. Right? Here in case of basic medium, we can balance. Here in basic medium, add water molecules, and at the same time on opposite side add required number of OH minus ions. Right? In basic medium, add number of water molecules, in basic medium add number of water molecules, and on opposite side add equal number of OH minus ions. Equal number of OH minus ions. Next, balance the charges. Balance the charges. Fifth step. Balance charges on both sides, both half reactions. Next, equalize the number of electrons. To equalize the number of electrons, to equalize the number of electrons, to equalize the number of electrons, multiply with suitable number. Multiply with suitable number. Next, add above two half reactions. Add above two half reactions. When the common terms will get cancelled, that means number of electrons, then we finally get the balanced chemical equation. Add above two half reactions, then we get a balanced chemical equation. We get balanced chemical equation. Okay, right? So these are the steps we should follow the balanced chemical equation by ion electron method. First, classify into two half reactions: oxidation half reaction and reduction half reaction. Next, balancing the atoms other than oxygen and hydrogen. To balance the oxygen, add water molecule. To balance the hydrogen in acidic medium, add H plus ions. Whereas in basic medium, add H2O molecules and same number of OH minus ions on opposite side. Next, balance the charges. After that, to equalize the number of electrons, multiply with suitable number. Next, add above two half reactions. Then finally, we get the balanced chemical equation. Finally, we get balanced chemical equation. Okay. To equalize the number of electrons, multiply with suitable number. Then, by adding above two half reactions, we get balanced chemical equation. Okay, students. Now, let us see one example in acidic medium. Redox reaction in acidic medium by ion electron method. Balancing a redox reaction in acidic medium by ion electron method. Okay. Next. My dear students, let us see one important problem. Balancing a chemical equation by ion electron method. Here the equation is MnO4 minus C2O4 minus 2 gives rise to Mn plus 2 and CO2. That means here it is in H plus. H plus means what? Remember, H plus means balancing a chemical equation in acidic medium. H plus or acidic medium. Okay, right. First of all, classify the equation into oxidation of reaction and reduction of reaction by finding oxidation number. See here MnO4 minus term, right? MnO4, here Mn. Observe here, what is the oxidation number of MnO4 minus ion in Mn? Mn oxidation number. Mn oxidation number, here Mn oxidation number. Here charged species oxidation number is plus 2, right? Here oxidation number is plus 2, right? Here MnO4 minus, in MnO4 minus Mn we don't know, let us consider X plus 4 into each oxygen minus 2, 4 into minus 2, X minus 8 equal to minus 1, then X equal to plus 7. That means plus 7 to here plus 2. This is a reduction half reaction. Why it is reduction half reaction? Why? Because oxidation number decreases. Here in MnO4 minus ion, Mn oxidation number is plus 7, whereas Mn plus 2 ion oxidation number is plus 2. Plus 7 to plus 2 means decrease in oxidation number, reduction of reaction. Now another one is oxidation of reaction. Here C2O4 minus 2 ion, here CO2. Here find the oxidation number of carbon from this one. This is oxidation of reaction. In CO2, oxidation number of carbon is plus 4. Whereas in case of C2O4 minus 2, this is charged species. In charged species, oxidation number of individual atom here 2 carbons, 2x. 2x plus 4 into minus 2. So 2x minus 8 equals to minus 2. 2x equals to 6, x equals to 3. Here 3 to 4. 3 to 4 means oxidation number. 3 to 4 means oxidation number of carbon is increases. Here oxidation number C2O4 minus 2 to CO2. Here C2O4 minus 2 plus 3 to here plus 4. Okay. See on this side MnO4 minus gives rise to Mn plus 2. On this side C2O4 minus 2 to CO2. This is oxidation of reaction. This is reduction of reaction. This is oxidation of reaction. Okay, classify this oxidation of reaction and reduction of reaction. Now, step 1, balancing other than oxygen and hydrogen. Here Mn. Other than oxygen means Mn is present. Here Mn. Here both are same. As to you have to represent MnO4 minus gives rise to Mn plus 2. Here 2 carbons, here only 1 carbon. Simply just you have to write C2O4 minus 2 gives rise to 2 CO2. Other than oxygen hydrogen, that means carbon is present, carbon is balanced here. In the second step, balancing the oxygen. To balance the oxygen in acidic medium, we should add, to balance the oxygen, we should add water molecule only. MnO4 minus. See, MnO4 minus. Here, how many oxygens? 4 oxygen atoms. Here, no oxygens. 4 oxygen means we should add 4 water molecules on required side. On which side? Left side, 4 oxygen atoms are present. On right side, there is no oxygen. Instead of oxygen, or to balance the oxygen, we should add water molecule. How many water molecules? Left side 4. Means the right side also 4 water molecule we should add. Mn plus 2 plus 4H2O. Oxygen is balanced. Next, here how many oxygens? 4. Here 4. No need to balance here. C2O4 minus 2. Here 2 CO2. Already balanced. Right? Next, in third step, to balance the hydrogen. To balance hydrogen in acidic medium. See, in left side, MnO4 minus, there is no hydrogens. Whereas in right side, 4 2s, 8 hydrogen atoms. Here in left side, there is no hydrogen atoms. So we should add number of H plus ions on required side. Required number of hydrogens. How many here? 8. So we should add 8H plus. 8H plus gives rise to Mn plus 2 plus 4H2O. Is it clear? See, to balance the oxygen, we should add water molecules. Required number of water molecules. Here 4 oxygens, we should add 4 water molecules. To balance the hydrogen, here 8 hydrogens. Here no hydrogens. So we should add 8 H plus ions on required side. Or required number of hydrogen plus ion, H plus ions. Right? Here H plus ion, hydrogen is balanced. Hydrogen is balanced. Now come to this side. Here hydrogens are present, no hydrogen. Simply as you have to write absent, hydrogens are absent. 2CO2, hydrogen is absent. Next, this is important one. Here, be careful here. To balance the charges, here MnO4, total MnO4 here minus ion, that means 1 negative. 8 H plus ion means 8 positive ions. H plus ion means positive ion. How many positive ions? 8. Here total negative ions MnO4 minus. Total MnO4 on MnO4 1 minus ion. That means 1 negative ion, 8 positive ion. Total value net charge is 7. Come to the right side. Mn plus 2. How many positive charges? Plus 2. Right? Here total 7 positive. Here 2 positive. How many electrons are required to get positive charge? Positive plus 2 charge. Here. To balance the charges, we should add required number of electrons. See, MnO4 minus plus 8H plus. See, 8 positive, 1 negative. That means net value is, net charge is plus 7. Here left side plus 7, here plus 2. How many electrons are added to get the charge is balanced? We should add 5 electrons. Why? Because, see, observe here, 5 electrons. Electron means negative charge. Then we get the Mn plus 2 plus 4H2O. Once again, listen here. 8 positive ions, 1 negative ion. Total net charge is plus 7. But on right side, plus 2 charge is present. To balance the plus 2, here plus 7. How many electrons are added? On left side, 5 electrons. Why? Because 5 negative charge, 8 positive charge, 1 negative charge. That means here 8 positive, 1 negative, 5 electrons also negative. 5 and 1. 6 negative charges, 8 positive charges. Net charge is 2. Here 2. Now the charge is balanced. Charges are balanced. Is it clear? Charges are balanced. Now come to the right side. C2O4 on C2O4 oxalate ion, here minus 2. Here CO2. Simply to balance the charges C2O4 minus 2, we should add on right side 2 electrons. Why 2 electron means 2 negative charges now? 2 negative charges on left side here. Whereas we should add 2 electrons. Electrons contain negative charge. 2 negative charge, 2 negative. Charges are balanced. Here charges are balanced. Is it clear? Charges are balanced. Next, equalize the electrons with suitable number. Equalize. How many electrons here? 5 electrons. Here 2 electrons. By multiplying which number, we get the equal number of electrons. Simply just try to multiply here 2 with 5. Here 5 with 2 electrons. Multiply the total reaction with a suitable number, we get the 10 electrons here. For example, we multiply with 2. To all this MnO4 minus 8H plus and 5 electrons. 2 5 is 10. Here also multiply with 5. Here multiply with 2. Multiply with 2 to above equation. To above equation. Simply directly you have to write 2 MnO4 minus plus 16H plus 10 electrons. We get the 2 Mn plus 2 plus 8H2. Here multiply with 5 to above equation. multiply with 5 to the above equation. See, 5 C2O4 minus 2 gives rise to, okay, 5 to 10 CO2 plus 5 to 10 electron. Now add above two half reaction. Next step is add above two half reactions. Add above two half reactions. Two half reactions. See, just have to represent the all reactant on one side. All reactant one side, all product another side. 2 MnO4 minus plus 16H plus 10 electrons plus 5 C2O4 minus 2 gives rise to, now, product 2 Mn plus 2 plus 8H2O plus 10 CO2 plus 10 electrons. See here 10 electrons left side, 10 electrons right side gets cancelled. Here MnO4 minus term. Here any MnO4 minus term is present? No. Just you have to write 2 MnO4 minus plus. Here 16H plus. Here there is no H plus term. As you have to write 16H plus plus. 10 electrons gets cancelled. Now 5 C2O4 minus 2. 5 C2O4 minus 2 gives rise to. See how many Mn plus 2 here? 2 Mn plus 2 plus 8H2O plus 10 CO2. Observe here 2 Mn, 2 Mn. Okay. 16H plus means here 8 2s 16H hydrogens. 5 2s 10, 10 C carbons. 5 4s 20, 20 and 2 4 8, 28 oxygens. Here 8 oxygens, 10 2s 20, 20 plus 8, 28 oxygen. Here each and every atom is balanced. So this is finally balanced chemical equation. Balanced chemical equation. Balanced chemical equation. Is it clear? In the first step, classify the both half reactions, oxidation and reduction half reactions. Next, to balance the other than oxygen and hydrogen atom. Next one is balance the oxygen atom, we should add required number of water molecule on deficient side. To balance the hydrogen, add required number of H plus ions on deficient side. Now here carefully to balance the charges. MnO4 minus, that means 1 negative charge. 8H plus means 8 positive charge. 8 positive, 1 negative means total net charge is plus 7. Whereas on right side only plus 2. To equalize that, plus 7 we should add 5 electrons. Why? Because electrons are having negative charge. 7 positive, 5 negative charges. That means 2 positive. Here also Mn plus 2. In this way we can balance the charges. Next, multiply the above equation with suitable number. Simply just you have to multiply with here 5, here 2. Just to multiply with 2 to these reactants and products. Here multiply with 5 the reactants and products. Then add about two half reactions. Finally we get a balanced chemical equation. Okay students, right? In the next video we are going to discuss one more example in acidic medium and then basic medium. Okay, thank you very much.